Hello, so today I am going to discuss the handshaking theorem in graph theory. What does the theorem say? The theorem says that in a graph, if I take the degree sum of all the vertices, then that will be equal to twice the number of edges. Okay, that means if a graph is having n number of vertices, v1, v2, v3 and so on till vn, then if I take the degrees of all of them and if I add the degrees, then that will be twice the number of all the edges, or 2 into the cardinality of the edge set. So how do I prove this? See, let E belongs to capital E, that means E is an edge. Okay, so how will E look? E will look something like this. VI, isn't it so? Because that is the definition of an edge. Edge is what? An unordered pair of vertices. That means a set of cardinality 2 where both the elements are what? Some vertices. Now here you see the degree of Vi and the degree of Vj. In both of them this E will be included. Isn't it so? That means since Vi and Vj are adjacent according to my assumption, that means in the degree of Vi this one is included, and also in the degree of Vj also this one is included. So basically what is happening, E is participating in dvi and dvj both. Now this is true for all the edges, isn't it so? Each edge is participating in 2, isn't it so? So that means what? If I add, then that will be what? Twice of the cardinality of edge set E. Now there is a corollary result which is very interesting and which I am going to show you now. And what is that result? So what is the statement? The statement is that in a graph, the number of vertices having odd degrees is even. That means I am taking a graph and I am taking those vertices which have odd degrees. Okay, and if I observe, then the number of those vertices will be an odd number. Now how do I give an example? See, I have drawn a graph. Okay, now let me identify the vertices which are having odd degrees. So what are those vertices which are having odd degrees? See, this one is having degree 3, isn't it so? 3 edges are incident. So this one, again this one is also having odd degree. What is the degree? Its degree is also 3. Now is anyone else having an odd degree? This degree 2, this one has degree 2, this one also has degree 2, this one also has degree 2. Now you see the vertices which are having odd degrees are 2 in number, this one and this one. Okay, so this is true for all graphs. Now this was an example, but I will show you a proof. Now see, I will use the handshaking theorem. What does the handshaking theorem say? That the degree sum is equal to twice the cardinality of the edge set, or twice the number of the edges of the graph. Okay, this is from the handshaking theorem, which I just now discussed with you. Now let me separate the vertices which are having odd degrees and even degrees. Degree is what? Degree is an whole number, is a whole number, right? Degree is basically a whole number, so either it will be odd or it will be even, right? Let the vertices having odd degrees be v1, v2, v3 and so on till suppose vk. Okay, let k number of vertices be having odd degrees. Okay, now what I am going to do, okay, I assume that the total number of vertices is n. What I did, I took the vertices having odd degrees and their number is suppose k. That means v1, v2 till vk. I don't know what is k. K can be anything. So what is basically the degree sum? The degree sum is nothing but the sum of the degree of all the vertices. So I am separating the degree sum of odd vertices and I am separating the degree sum of even vertices. Okay, now if you observe the left hand side is what? Twice of e. Okay, if I want to simplify this expression, then this is dvi where I is ranging from 1 to k. Again this will be a summation dvj where j is ranging from k plus 1 till n. Right, now you see this is an even number. Is this an even number? See, these are all odd. Okay, d of v1, d of v2, these are all odd numbers. Basically I took the odd vertices, means vertices having odd degrees. So these are all what? Odd numbers. And these are all even numbers. What are the even numbers? D of vk plus 1, d of vk plus 2 till d of vn. So this is what? This is basically a sum of even numbers. So is this even? Yes, this is even. Why? Because I take any number of even numbers and I add them, I will always get an even number. So this is also even and this is also even. Now what if I take this one this side? Okay, now this is also even, this is also even, and the difference of two even numbers is also even. So that means what? That means this whole thing is even. So finally I have proved that this is what? This is even. Okay. Now basically d of v1 plus d of v2 till d of vk is an even number, but these are all odd numbers. If you recall, d of v1, d of v2, d of vk, these are all odd numbers, and since the summation of odd numbers is turning out to be even, isn't it necessary that k must be even? See, the summation of odd numbers will be even if and only if the number of those odd numbers is even. Okay, this is a very interesting result. If you don't know it, then you should look it up. Okay, so what did I get? K is an even number. Okay, K is even. I hope you liked this video, and please subscribe, like and share if you wish to see my content more often. Thanks.